Imagine a world unlike any other, one that seems to defy the very rules of the universe. A massive, icy planet that doesn't spin like the others, but rolls through space as if knocked over by a cosmic accident. A place where the sun rises in the north and sets in the south, where a single year lasts longer than an entire human lifetime, and where furious winds tear through a frozen, methane-rich sky. Welcome to Uranus, the sideways giant of the solar system. It may not be the most famous planet, but it's certainly one of the strangest. From its bizarre rotation and mysterious rings to the violent storms hidden beneath its serene blue atmosphere, Uranus challenges everything we thought we knew about the cosmos. In this journey, we're diving deep into the secrets of this distant world. How was it discovered by pure chance? What caused its extreme tilt? Could there be hidden oceans beneath its icy moons? And most importantly, why is Uranus so different from everything we know? Buckle up, space explorers, because we're about to embark on an unforgettable mission to uncover the truth about this alien planet. If you're ready for the adventure, don't forget to like this video and subscribe to Exploring the Universe so you never miss a new discovery from the vast unknown. Now, let's take off. Picture this. It's 1781. And William Herschel is just a music teacher who loves stargazing. He's built his own telescope in his backyard in Bath, England, grinding the mirrors by hand with his sister Caroline by his side. Night after night, they're mapping the sky, cataloguing every star they can find. Then, on March 13th, something catches William's eye. There's this fuzzy, greenish dot that doesn't quite look like the others. At first, he thinks it might be a comet, maybe something passing through our solar system. But as weeks turn into months, William notices something incredible. This object isn't behaving like a comet at all. It's moving in a perfect circle around the sun, just like the other planets. The astronomical community goes absolutely wild. For thousands of years, humans had known about 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. These were the wandering stars that ancient civilizations tracked across the night sky. But now, suddenly, the solar system had doubled in size overnight. Here's what makes this discovery even more remarkable. Uranus had been hiding in plain sight all along. If you know exactly where to look and have perfect dark skies, you can actually see Uranus with your naked eye. It appears as the faintest little star, barely visible. Ancient astronomers like Hipparchus and even Galileo had actually recorded it in their observations, but they all thought it was just another distant star. Why did they miss it? Uranus moves so incredibly slowly across the sky that it takes 84 Earth years to complete one orbit around the Sun. From our perspective, it barely seems to move at all. Imagine trying to notice that a clock hand had moved when it takes decades to shift just a tiny bit. William Herschel wanted to name his discovery after King George III, calling it Georgium Sidus, or George's Star. Can you imagine if we were talking about the planet George today instead of Uranus? Thankfully, other astronomers suggested naming it after the Greek god of the sky, following the mythological tradition of the other planets. This discovery didn't just add another planet to our cosmic neighborhood. It fundamentally changed how we think about space. If there was one unknown planet out there, could there be others? This question would drive astronomers to keep searching, eventually leading to the discovery of Neptune and later, Pluto. The moment William Herschel spotted that little green dot through his homemade telescope, he accidentally opened the door to the modern age of astronomy. He showed us that the universe was far bigger and more mysterious than anyone had ever imagined. Picture this. You're watching all the planets in our solar system doing their cosmic dance. Mercury spins upright, Venus has a slight tilt, Earth leans at 23.5 degrees, Mars tilts similarly to Earth. Then you get to the outer planets, and they're all behaving pretty normally too. But then, there's Uranus, and it's doing something absolutely mind-blowing. While every other planet spins like a top, Uranus literally rolls through space like a bowling ball tumbling down an alley. Its axis is tilted 98 degrees, which means it's basically lying on its side as it orbits the Sun. Think about that for a moment. If Earth did this, the North Pole would sometimes point directly at the Sun for 42 years straight. Then the South Pole would get its turn for another 42 years. So what on Earth, or should I say what in space, could have caused this cosmic catastrophe. The leading theory reads like something from a science fiction disaster movie. Scientists believe that billions of years ago, when our solar system was still young and chaotic, Uranus was minding its own business, spinning normally like all the other planets. Then suddenly, out of the darkness of space, came a massive object, roughly the size of Earth. Imagine the moment of impact. This wasn't just any collision. This was a cosmic knockout punch that literally knocked Uranus sideways. The force was so tremendous that it changed the planet's entire orientation forever. But here's where the story gets even more fascinating. Some scientists wonder if this single catastrophic event could really explain everything we see today. You see, when you knock something over that dramatically, you'd expect to see evidence everywhere. But Uranus has managed to keep its moons in relatively neat, orderly orbits around its new tilted equator. It's almost as if the moons said, well, if you're going to roll instead of spin, we'll just adjust our orbits to match. This suggests that either the impact happened very early in Uranus's formation, when everything was still settling into place, or something even more complex occurred. Some researchers propose that maybe it wasn't just one giant collision. Perhaps Uranus endured multiple smaller impacts over millions of years, each one gradually nudging it further and further onto its side. It's like being slowly pushed over rather than receiving one devastating blow. But here's the truly wild part about Uranus rolling through space. It creates the most extreme seasons imaginable. For 21 Earth years, one pole experiences continuous daylight, while the other sits in complete darkness. Then, as Uranus continues its 84-year journey around the Sun, the seasons gradually shift until the situation completely reverses. The atmospheric consequences are mind-boggling. Imagine trying to predict weather patterns on a world where the sun might not rise for decades, then suddenly becomes a permanent fixture in the sky. The temperature differences between the permanently lit and permanently dark hemispheres create wind patterns unlike anything we see on other planets. What makes this even more intriguing is that despite this bizarre orientation, Uranus somehow maintains a relatively stable system. Its rings, discovered much later, orbit around its equator in perfect alignment with its tilted axis. It's as if the entire Uranian system collectively decided to embrace this new sideways lifestyle. The discovery of Uranus's unusual rotation fundamentally changed how we think about planetary formation. It proved that our solar system's history was far more violent and chaotic than we initially imagined. It showed us that planets aren't immune to cosmic accidents that can completely alter their character forever. And if you think about it, there's something almost endearing about Uranus's rebellion against cosmic norms. While every other planet follows the expected rules of rotation, Uranus just decided to do its own thing. Whether it was by choice through some cosmic mishap, or forced into this position by a devastating collision, Uranus stands as a reminder that even in the ordered dance of the solar system, there's always room for the unexpected and extraordinary. For centuries, Saturn held the crown as the only planet with rings. Its magnificent, shimmering bands captivated astronomers and dreamers alike, making it the undisputed jewel of our solar system. But in 1977, everything changed when scientists made a discovery that would rewrite what we knew about planetary rings forever. It started with what seemed like a routine observation. Astronomers were watching Uranus pass in front of a distant star, an event called an occultation. They expected to see the starlight dim once when Uranus blocked it, then brighten again when the planet moved on. Instead, something extraordinary happened. The starlight flickered and dimmed multiple times before Uranus even reached the star, then flickered again after the planet had passed by. At first, the scientists couldn't believe what they were seeing. The data suggested that Uranus had rings, but that seemed impossible. How could a planet have rings that no one had ever noticed before? The answer lay in the nature of these rings themselves. Unlike Saturn's brilliant icy rings that reflect sunlight like cosmic mirrors, Uranus's rings are made of some of the darkest material in the solar system. These rings are so dark they absorb almost all the light that hits them, making them nearly invisible even to powerful telescopes. Imagine trying to spot a piece of charcoal floating in the darkness of space. That's essentially what astronomers had been attempting to do for hundreds of years without even knowing it. The discovery revealed 13 distinct rings around Uranus, each one narrow and incredibly dark. Scientists believe these rings are composed of organic compounds that have been radiation darkened over millions of years, creating material darker than fresh asphalt. Some of these rings are so thin that if you could walk across one, it would be like crossing a road rather than a highway. But the mystery of Uranus goes far beyond its hidden rings. This planet exists in a realm of cold so extreme it defies imagination. At -371 degrees Fahrenheit, Uranus holds the record as the coldest planetary atmosphere in our solar system. To put this in perspective, this temperature is so frigid that if you took a breath of Earth's air and somehow transported it to Uranus, every molecule would instantly freeze solid. At these incredible temperatures, something magical happens to methane in Uranus's atmosphere. The methane doesn't just freeze into ice crystals like water would. Instead, the extreme pressure and cold create conditions so intense that scientists believe diamonds actually form and fall like snow through the planet's interior. Picture this. Beneath those dark rings and blue-green clouds, there might be a literal diamond rain falling through layers of liquid methane. These aren't tiny diamond specks either. Computer models suggest that some of these diamonds could be massive, potentially weighing thousands of carats as they slowly sink toward the planet's core. It's like nature's most extravagant jewelry store, completely inaccessible and hidden beneath an atmosphere that would instantly kill any visitor. The size comparison makes Uranus even more remarkable. If you placed Earth next to Uranus, our home planet would look like a tennis ball sitting next to a basketball. Yet despite being only about 4 times wider than Earth, Uranus contains 14.5 times more mass. This incredible density comes from its composition as an ice giant, packed with water, methane, and ammonia ices surrounding a rocky core. What makes this density so fascinating is that Uranus manages to be both massive and surprisingly light, compared to the true gas giants Jupiter and Saturn. It's like comparing a bowling ball to a beach ball that somehow weighs almost as much. This unique composition contributes to Uranus's strange magnetic field and helps explain why it radiates so little heat compared to other giant planets. The discovery of Uranus's rings fundamentally changed how scientists think about ring systems. It proved that rings aren't rare, spectacular exceptions, but might actually be common features of giant planets. This revelation led to more careful observations of other planets and eventually to the discovery of rings around Jupiter and Neptune as well. Today, when we look at Uranus through our most powerful telescopes, we see a world that embodies cosmic contradictions. It's a giant that spins on its side, an ice world hot enough inside to rain diamonds, and a planet with rings so dark they remained hidden for centuries. Each new discovery about this mysterious ice giant reminds us that our solar system still holds secrets waiting to be unveiled, hidden in the cold depths of space where diamonds fall like snow and rings float invisible in the cosmic darkness. It's 1986, and after nearly 9 years of traveling through the cold emptiness of space, a small robotic explorer the size of a compact car is about to make history. Voyager 2, launched back in 1977, had already stunned the world with incredible close-up images of Jupiter and Saturn. But now it was approaching something completely different. The mysterious ice giant Uranus, a world that had remained largely a puzzle since its discovery 2 centuries earlier. The tension was incredible. This wasn't just another planetary flyby. This was humanity's one shot at getting a close look at Uranus. The spacecraft would zip past the planet in just a few hours, and there would be no second chances. Everything had to work perfectly. The cameras, the instruments, the radio signals traveling billions of miles back to Earth. Any failure would mean losing our only opportunity to truly understand this strange, tilted world. And what Voyager 2 discovered during those precious few hours was absolutely mind-blowing. The spacecraft revealed that Uranus wasn't the boring, featureless ball that many scientists expected. Instead, it found a world full of surprises. Massive storms raging through the methane-rich atmosphere, a collection of dark, narrow rings that nobody knew existed, and 27 moons, some looking like they'd been shattered and reassembled multiple times. But perhaps the most shocking discovery was Uranus's magnetic field. Scientists expected it to be aligned with the planet's rotation, like Earth's magnetic field. Instead, Voyager 2 found something completely chaotic. A magnetic field tilted 60 degrees off the planet's axis and wobbling wildly as Uranus spins. It was like discovering that the planet's internal compass was completely broken. The really fascinating part. Voyager 2 gathered all this incredible information in less than 6 hours of close approach. Think about that. Everything we know about Uranus in detail comes from those few precious hours when a small robot, traveling at tremendous speed, managed to peek behind the curtain of one of our solar system's most secretive worlds. But here's the thing that might surprise you. We've never gone back. Not once. In the nearly 40 years since Voyager 2's historic flyby, no other spacecraft has visited Uranus. It's like humanity got one quick glimpse through a keyhole and then walked away, leaving countless mysteries unsolved. Why haven't we returned? The answer is both simple and frustrating: distance and time. Uranus is so incredibly far away that even with our best rockets, any mission we launch today wouldn't arrive until around 2040. That's a 15-year journey through the depths of space, longer than most people's entire careers. It's a commitment that spans generations. There's also the challenge of timing. The planets have to align just right to give a spacecraft the gravitational boosts it needs to reach Uranus efficiently. These perfect launch windows only come around every few decades, making mission planning incredibly complex. But here's the exciting news. Scientists and engineers are finally serious about going back. Both NASA and the European Space Agency are developing plans for new Uranus missions in the 2030s. The proposed Uranus orbiter and probe mission wouldn't just fly by like Voyager 2, it would actually orbit the planet for years, studying its atmosphere, rings and moons in unprecedented detail. Imagine what we might discover. Could those mysterious moons harbor hidden oceans beneath their icy surfaces? What's really causing those massive storms in Uranus's frigid atmosphere? And why is the planet's magnetic field so utterly chaotic? These are questions that have been waiting nearly 4 decades for answers. The truth is, Voyager 2's brief encounter with Uranus was like reading the first page of an incredible book and then having to wait half a century to read the rest. But that wait might finally be coming to an end. Our generation could very well witness the next chapter in humanity's exploration of the sideways planet, and who knows what incredible secrets we'll uncover when we finally return to this distant, frozen world, spinning alone in the outer darkness of our solar system. Here's something that will absolutely blow your mind. Uranus has the coldest atmosphere in our entire solar system, even colder than Neptune, which is actually farther from the Sun. We're talking about temperatures that drop to minus 370 degrees Fahrenheit. That's so cold that if you could somehow visit there, the methane in the atmosphere would literally freeze solid around you. But here's where it gets really weird. Despite being this frozen wasteland floating in space, Uranus is far from peaceful. Imagine winds screaming across the planet at 560 miles per hour. That's faster than the most devastating hurricanes we've ever seen on Earth. These aren't gentle breezes we're talking about. These are atmospheric rivers of destruction that could tear apart anything in their path. Now, you might be wondering about that beautiful blue-green color that makes Uranus so distinctive when you see it through a telescope. That gorgeous hue comes from methane gas high up in the atmosphere. Here's how it works. When sunlight hits Uranus, the methane acts like a filter, absorbing all the red light and reflecting back the blue and green wavelengths. It's like the planet is wearing cosmic sunglasses that only let certain colors through. But the really mind-bending part is what scientists discovered about Uranus's weather patterns. For decades, astronomers thought this ice giant was essentially dead, a boring, featureless world where nothing much happened. The planet seemed to have almost no internal heat source, unlike other gas giants that are like cosmic furnaces burning from within. Without that internal energy driving weather systems, Uranus should theoretically be a calm, quiet place. Then something incredible happened that changed everything we thought we knew. In 2014, astronomers using the most powerful telescopes on Earth started seeing massive storms suddenly erupting across Uranus's surface. These weren't small disturbances. They were continent-sized tempests that appeared out of absolutely nowhere, raged for weeks, and then vanished just as mysteriously as they had begun. Scientists were completely baffled. How do you get these monster storms on a planet that barely has any internal heat? It was like watching a frozen lake suddenly develop massive waves during a perfectly calm day. The mystery deepened when researchers realized these storms seemed to follow Uranus's strange seasons. Remember, because Uranus is tilted on its side, each pole experiences 42 years of continuous sunlight, followed by 42 years of total darkness. As the planet slowly moves through its 84-year orbit around the Sun, different regions get their turn in the cosmic spotlight. Scientists now think these extreme seasonal changes might be the key to understanding Uranus's violent weather. Here's the theory that's getting researchers really excited. As sunlight finally reaches areas that have been in darkness for decades, it creates massive temperature differences across the planet. These temperature gradients become like atmospheric pressure cookers, building up energy until they explode into those mysterious giant storms. But there's still so much we don't understand. Some scientists believe there might be hidden heat sources deep inside Uranus that we haven't detected yet. Others think the planet's chaotic magnetic field might be stirring up the atmosphere in ways we can't even imagine. The truth is, Uranus keeps surprising us every time we look closer. What makes this even more fascinating is that these atmospheric mysteries have real implications for understanding planets beyond our solar system. Astronomers have discovered thousands of exoplanets that are similar in size to Uranus, and many of them probably have similar atmospheric conditions. By solving the puzzle of Uranus's weather, we might unlock secrets about distant worlds orbiting other stars. The most incredible part? Every time we think we've figured out Uranus, it does something completely unexpected. Just when scientists thought they understood its calm nature, boom, massive storms appear. When they think they've mapped its wind patterns, the planet shifts and changes like it has a mind of its own. Standing on Uranus, if such a thing were possible, would be like experiencing an alien world where the very air around you defies everything we know about planetary science. The methane snow falling upward in those supersonic winds, the eerie blue-green twilight filtering through the toxic atmosphere, and the knowledge that you're standing on a world that continues to baffle the brightest minds in science. It's both terrifying and absolutely magnificent. You're floating through space, approaching Uranus, and suddenly you encounter not one, not two, but 27 moons dancing around this tilted giant. Each one tells a story of cosmic violence and mystery that would make any science fiction writer jealous. Let's start with Miranda, perhaps the most puzzling moon in our entire solar system. When Voyager 2 first captured images of this small world back in 1986, scientists literally gasped at what they saw. Miranda looks like someone took a celestial jigsaw puzzle, threw the pieces into a blender, and then tried to put them back together while blindfolded. Its surface is a patchwork of completely different terrains, smooth plains sitting right next to jagged cliffs that stretch 12 miles high. To put that in perspective, that's nearly twice the height of Mount Everest, except these cliffs drop straight down into dark canyons. The leading theory suggests that Miranda was completely shattered by a massive impact sometime in its distant past, then slowly reassembled itself through gravity. Imagine the moon literally exploding into chunks, floating apart in the cold darkness of space, and then gradually pulling itself back together like some cosmic Humpty Dumpty. But here's the kicker. This might have happened not once, but multiple times throughout Miranda's history. Then there's Titania, Uranus's largest moon and another geological wonderhouse. This world harbors canyons so deep and vast, they make Earth's Grand Canyon look like a scratch on a sidewalk. These aren't just simple cracks either. They're massive rift valleys that stretch for hundreds of miles across Titania's surface, some reaching depths of 3 to 4 miles. Scientists believe these formed when the moon's interior froze and expanded, literally tearing the surface apart like an ice cube cracking in your freezer, but on an unimaginably larger scale. What makes these moons even more intriguing is what might be hiding beneath their battered surfaces. Recent computer models suggest that several of Uranus's larger moons, including Titania and possibly even little Miranda, might harbor subsurface oceans of liquid water. Think about that for a moment. Beneath those frozen, crater-scarred surfaces, there could be vast oceans that have remained liquid for billions of years, protected by thick shells of ice. These hidden oceans aren't just academic curiosities. Wherever we find liquid water that's been stable for long periods, we start wondering about the possibility of life. Not little green men, of course, but microscopic organisms that might have evolved in those dark, subsurface seas. On Earth, we've discovered life thriving in the most extreme environments imaginable, from boiling hot springs to the deepest ocean trenches. Could similar microbial communities exist in the hidden oceans of Uranus's moons? The story becomes even more fascinating when you consider how these moons formed. Unlike our own moon, which likely formed from a giant impact with early Earth, Uranus's moons probably formed from the debris disk that surrounded the planet after that catastrophic collision that knocked Uranus onto its side. They're essentially children of cosmic catastrophe, born from the wreckage of whatever massive object slammed into Uranus billions of years ago. Each of these 27 moons is a time capsule, preserving evidence of that ancient collision and the chaotic early days of our solar system. Some are tiny, irregular chunks of rock and ice that are clearly captured asteroids. Others, like the 5 major moons, are more spherical and substantial, suggesting they formed in place from the debris disk. What's particularly captivating is how little we actually know about most of these worlds. Voyager 2's flyby gave us tantalizing glimpses, but it was like trying to understand the entire library by flipping through a few pages of random books. The planned missions to Uranus in the 2030s will hopefully give us the detailed, long-term observations we need to truly understand these mysterious companions. Until then, these moons continue their ancient dance around their tilted parent planet, keeping their secrets locked away beneath surfaces scarred by billions of years of cosmic history. Each one represents a chapter in the violent, beautiful story of how our solar system came to be, and possibly, just possibly, they might hold clues about life itself spreading throughout the cosmos. If you thought Uranus spinning on its side was weird, wait until you hear about its magnetic field. It's like nature decided to break every rule in the planetary physics textbook and then make up some new ones just for fun. Picture Earth's magnetic field for a moment. It's nice and orderly, running roughly from the North Pole to the South Pole, creating those beautiful aurora displays we see dancing across polar skies. It's predictable, stable, and behaves exactly like you'd expect from a spinning planet with a molten core. Now throw all of that out the window, because Uranus decided to be the rebel of the solar system in yet another spectacular way. When Voyager 2 approached Uranus back in 1986, scientists were expecting to find a magnetic field similar to the other giant planets. What they discovered instead left them scratching their heads and rewriting their theories. Uranus's magnetic field is tilted an incredible 60 degrees away from its rotational axis. To put this in perspective, imagine if Earth's magnetic compass didn't point to the North Pole, but instead pointed somewhere around northern Canada while wobbling wildly as the planet spins. But here's where it gets really mind-bending. This magnetic field doesn't just sit there being tilted. It actually wobbles and shifts as Uranus rotates, like a cosmic washing machine that's completely out of balance. As planetary geophysicist Dr. Carol Paty puts it, Uranus's magnetic field is like a magnet that someone melted and twisted on purpose. Every 84 minutes, as Uranus completes one rotation, this magnetic field swings around in a completely chaotic pattern. The result is something that shouldn't exist according to everything we know about planetary magnetism. Auroras that dance across the planet in seemingly random locations. On Earth, our auroras stick to the polar regions because that's where our magnetic field lines converge. But on Uranus, these spectacular light shows can appear anywhere on the planet, creating what scientists describe as a completely uncontrolled cosmic light display. Imagine standing on the surface of Uranus, if you could somehow survive the crushing atmosphere and bone-chilling cold. One day you might see auroras blazing across what you'd consider the northern sky, and the next day they could be dancing directly overhead or way down south. It would be like having the northern lights show up in Florida one night and Antarctica the next. The mystery deepens when you consider what causes this magnetic chaos. Most planets generate their magnetic fields through what scientists call a dynamo effect. Basically, liquid metal swirling around in the planet's core creates electrical currents, which in turn create magnetic fields. For this to work normally, the liquid metal needs to be rotating along with the planet in a relatively organized fashion. But Uranus seems to have missed that memo entirely. Scientists believe that the same catastrophic impact that knocked Uranus onto its side billions of years ago also completely scrambled its internal structure. Instead of having a nice, organized core where liquid metals flow in predictable patterns, Uranus might have a jumbled mess of different materials all swirling around in chaotic currents. Think of it like this. If Earth's core is like a well-oiled machine with all its parts working in harmony, Uranus's core is like that same machine after someone dropped it down a flight of stairs and then tried to put it back together without the instruction manual. It still works technically, but nothing about it makes sense anymore. This magnetic mayhem has real consequences beyond just creating wild auroras. The chaotic magnetic field means that Uranus has virtually no protection from the solar wind, those streams of charged particles constantly flowing out from the sun. While Earth's organized magnetic field deflects most of these particles away from our atmosphere, Uranus's scrambled field lets them through in unpredictable ways. What's particularly fascinating is that this magnetic field behavior might give us clues about what happened during that ancient collision. The fact that both Uranus and its neighbor Neptune have similarly tilted and offset magnetic fields suggests that both planets might have experienced similar catastrophic events in their past. It's like finding two crime scenes with the same unusual evidence. It tells you something significant happened, even if you're not quite sure what. Scientists are eagerly awaiting future missions to Uranus, planned for the 2030s, that will study this magnetic mystery in much greater detail. They want to understand not just how this chaotic field works, but what it can tell us about the violent early history of our solar system. Until then, Uranus continues its lonely journey around the sun, spinning on its side, while its twisted magnetic field creates that wild, uncontrolled light show in its skies, a constant reminder that in space, the impossible is just another day at the office. It's been over 30 years since humanity last got a close look at Uranus. The Voyager 2 spacecraft whizzed by in 1986, giving us just a quick snapshot of this mysterious ice giant before disappearing into the depths of space. But here's the thing that'll blow your mind. We're finally going back, and it's going to be absolutely incredible. Both NASA and the European Space Agency have been quietly cooking up plans for what could be the most ambitious mission to the outer solar system we've ever attempted. They're calling it the Uranus Orbiter and Probe, and if everything goes according to plan, we could launch sometime in the 2030s. Now I know what you're thinking. Why did it take us so long to go back? Well, here's where it gets really fascinating. Getting to Uranus isn't like taking a road trip to the grocery store. We're talking about a journey that spans nearly 2 billion miles, and even with our most advanced rockets, it would take about 13 years to get there. That means if we launched tomorrow, the spacecraft wouldn't arrive until around 2040. Think about that for a second. Some of you watching this video might have kids by the time this mission reaches its destination. But here's what makes this upcoming mission so special. Unlike Voyager 2, which just flew by and took some quick photos, this new spacecraft would actually stick around. It would orbit Uranus for years, studying every single detail we've been dying to understand. We're talking about mapping those dark, mysterious rings that are so faint we can barely see them from Earth. We're talking about diving deep into that bizarre atmosphere where winds scream at 900 miles per hour through clouds of frozen methane. And here's the part that gives me goosebumps every time I think about it. This mission would carry a probe that would actually plunge into Uranus's atmosphere. Imagine that moment when this little explorer, after traveling for over a decade through the cold emptiness of space, finally reaches its destination and starts sending back data about what it's like inside this alien world. The scientists are particularly excited about solving some of Uranus's biggest mysteries. Why is this planet so incredibly cold, even colder than Neptune, which is much farther from the sun? What's causing that crazy magnetic field that tumbles and spins like a broken compass? And those 27 moons orbiting around Uranus? Could any of them be hiding liquid oceans beneath their icy surfaces? But here's the bittersweet reality we're facing. Space missions like this take decades to plan, build, and execute. The engineers and scientists working on these plans today might be retired by the time the spacecraft actually launches. Some of the people dreaming about this mission right now might not even be around to see the incredible discoveries it makes. Yet that's exactly what makes space exploration so beautifully human, isn't it? We're planting seeds for future generations to harvest. We're asking questions that our children and grandchildren will get to answer. And somewhere out there, almost 3 billion miles away, Uranus just keeps spinning on its side, completely oblivious to our grand plans, waiting patiently for us to return. The really wild part is that by the time this mission launches, we'll probably have technology we can't even imagine today. The computers guiding this spacecraft to Uranus will make our current smartphones look like stone tools. Who knows what other mysteries of the solar system we'll have uncovered by then? So while we wait for the 2030s to roll around, Uranus continues its lonely dance through the outer solar system, carrying all its secrets with it. But not for much longer. Humanity is coming back, and this time, we're staying for the long haul. So here we are, at the end of our incredible journey to one of the most mysterious worlds in our solar system. And honestly, the more we learn about Uranus, the more it feels like we're staring at a cosmic riddle that the universe left just for us to solve. Think about it for a moment. We've spent centuries studying planets, building theories about how they should behave, how they should spin, how they should look. Then along comes Uranus, rolling through space like it's completely ignored every rule in the planetary playbook. It's tilted so far over that it's practically lying on its side, spinning in a way that makes every sunrise and sunset a completely alien experience. Those dark rings we talked about earlier, the ones so faint that we didn't even know they existed until 1977, remind us of something pretty humbling. Even in our own solar system, even with our most powerful telescopes, there are still secrets hiding in plain sight. Uranus kept those rings hidden for hundreds of years, just waiting for the right moment to reveal them to curious human eyes. And that bone-chilling cold we explored, colder than planets much farther from the sun, it's like Uranus is playing by its own rules entirely. Every time we think we understand how ice giants work, Uranus throws us another curveball that makes us scratch our heads and go back to the drawing board. But you know what the most beautiful part of all this is? Uranus isn't just challenging what we know about planets. It's reminding us of something much bigger and more wonderful. Our universe is absolutely bursting with mysteries, with phenomena so strange and unexpected that they stretch our imagination to its limits. Every time we point our telescopes at the night sky, every time we send a spacecraft to explore a distant world, we're basically admitting something incredible about being human. We're saying that we refuse to accept that what we can see from our little blue planet is all there is to know. We're driven by this beautiful, almost childlike curiosity that keeps pushing us to ask bigger questions and seek stranger answers. Uranus has been out there for billions of years, rolling along its orbit, completely indifferent to whether we understand it or not. But here we are, these tiny creatures on a small rocky planet, determined to figure out its secrets anyway. There's something almost magical about that determination, isn't there? And the really exciting part is that Uranus is just one puzzle piece in an infinite cosmic jigsaw. Right now, as we speak, there are probably phenomena happening in distant galaxies that would completely blow our minds. There are probably discoveries waiting for us in our own solar system that we haven't even dreamed of yet. So, as we wrap up our exploration of this sideways ice giant, remember that every question Uranus has raised leads to 10 more questions about other worlds, other possibilities, other mysteries waiting out there in the darkness. The universe isn't just vast, it's endlessly creative, constantly surprising us with new ways to be absolutely extraordinary. And that's the real gift Uranus gives us. It reminds us that no matter how much we learn, no matter how smart we get, there will always be something out there that makes us feel like excited kids again, wondering what incredible discovery is waiting just around the corner. If this cosmic journey has sparked your curiosity even a little bit, I'd love for you to join our space-loving community here at Exploring the Universe. Hit that subscribe button and ring the notification bell so you never miss our next adventure through the cosmos. Give this video a thumbs up if Uranus surprised you as much as it surprised me. And definitely share it with anyone in your life who loves getting their mind blown by the wonders of space. Trust me, we've got so many more incredible destinations to explore together, and I can't wait to see you on our next stellar journey.